Hello, welcome to the workshop. It's Wednesday.
Hello.
How is everybody? Welcome. I hope you're
Hope
all
you're all
good.
well. Jinx.
No, Twitch isn't being bad again. Twitch is being fine today. We're just talking about... someone was asking about the resolution, and I was explaining that the fact that we stream at 936p is optimal for Twitch, because it also tricks Twitch into giving us the selector for resolutions constantly. So today we're transforming everything.
Quite literally.
Yep. So we'll be covering the transform. We're going to be covering transform, the Logix and the components parts of transform, and then we'll be doing some odds and ends.
If we have time.
You'll understand the end. Yeah, but we're going to be doing odds and ends. You'll get the end bit at the end, by the way. We have quite an important announcement to make at the end of the stream today, so we'll be getting on with that. So let's switch these two to broadcast so you can actually hear them a lot better now.
I'm in your head.
I'm in your head!
Broadcast, okay.
I'll broadcast you. Oh, looks like chat got to see the stream UI for a moment. Spoilers. So yeah, we'll put that up there so chat can see it. There we go. So who wants the camera first?
I will begin.
Okay, so we'll pass the camera over to Ryuvi, which is that one. And off you go.
So, the main thing we're going to be covering today is this set of nodes and some components and other things further down the line, but mainly we're going to be covering the transform folder in the Logix nodes browser, which this folder contains nodes that allow you that deals with space and spatial transformations and converting the transforms of an object from one space to another, and etc. That sounds all complicated, but really it means to move things around, regardless of if something is parented to something else or not. And there's a few subcategories of nodes here that I'd like to cover in the main transform folder, as well as its only subfolder, bounds. We have a lot of nodes in here, but we have nodes that, to start off, we have nodes that give us the axial directions of a slot. So let's say my hand here, its forward is this direction, and this node, the forward node, would in essence give you that direction in global space, which I will get to what global and local is in just a moment. Same thing with up, down, left, right. All your major axes of any object you can access in global space using these nodes. Shadowx says, transformation is what I've been struggling with for the past weeks. Perfect timing. Yes, transformation for me in the very beginning when I was learning Logix was a bit of a struggle, but now that I understand it, it's really useful, really fun, and I hope I can present some understanding here. But, moving on, we have two sets of nodes here which allow you to convert from global to local, and local to global, things like a direction, a point in space, a rotation, a scale, and a vector. Now, before I move on, I'd like to talk about what global and local is. So if you make an object, let's see, I'll make, for instance, a cylinder. This cylinder, if we look at it and parent it under nothing, it is in global space. And what that is anything that's underneath the root is in global space, meaning that its coordinates are relative to absolute origin, if I reset the rotation and the position, then it goes all the way over there, which is the root of the world, the origin. The global origin, I should say. Now, every object has its own local information as well. And anything parented underneath an object is locally transformed relative to the object. So, for instance, if I duplicate our cylinder here, and I parent this new cylinder underneath this one, then its transforms become relative to this object that I parented under becomes its new origin. So if I take this cylinder's position and reset it, instead of going to the world origin over there, it will go to its parent's origin, which is our cylinder here. And same thing with rotation and scale. You'll also notice that its transforms are, again, relative to the thing that it's parented to, its local space. Whereas if I take this cylinder and put it back underneath root, you'll see that its position, rotation, and etc. changes so that it's now referring to this position relative to the origin, global space. And you can access either the local transformation of the object underneath what it's parented to, or using the global nodes, you can do that in global space. Now there's reasons why you would want to use either, but I'll be getting to that a little bit later. Moving on, we have, aside from these, which allow you to convert something from global to local, or from local to global, either way, which I'll demonstrate later. We have nodes which, given a slot, it gives you either the local transformation, which is the position, rotation, and scale, or the local one. I probably shouldn't have deleted these cylinders, but I'll make more cylinders. So, for instance, if we have and I want to
We are currently aware of audio issues that Raivi's having. We're just dealing with them right now. Sorry about this, guys.
It looks like my mod mic has decided to be finicky, so you're going to have to deal with slightly lower audio quality. Apologies about that. Let's see. I don't know when my audio cut out, but I hope it wasn't too much. I can always repeat. Okay, good. Good. So, as I was attempting to say before my microphone decided to die, or did I say webcam? I meant microphone. I have two cylinders here. I have one parented to the other, and let's say I want to get either its local or global transformations, so I can demonstrate what these do. So, given our slot here, if I plug a reference into both of these, then the local transform says blah, blah, blah. But if we take a look at its position and such in the inspector here, we'll see that these values here show you this object's local transformation. Regardless if I choose position or rotation, you can see these values match. Consequently, though, if I choose global position, these numbers aren't the same because the inspector values here show you the slot's local transformations innately, whereas if we want to get the global transformation, which is this object not relative to the thing it's parented to, but relative to the root, then the global transform nodes allow you to do that, even if it is parented to something else. So as I move this around, it gives me the global coordinates, whereas this, the local transforms, will always give me the local coordinates. Like so. I'll leave these cylinders out because I will probably need them again, I don't know. Anyhow, next we have our global axis setters. And what these do is, given a slot that you want to change and a direction, this will set that specific direction of the object to what you want it to. So I'll use these cylinders again. Cylinders. So if I say I want to set the up direction, which is the green arrow here, let me rotate this to make it not up. There we go. So if I want to set the up direction of our cylinder here to something else, let's say 0, 0, 1. When I pulse this, it will change. It will basically say, okay, this green arrow, aligned that with the direction that I chose, which in this case would be the z-axis because it's the third item there. If I pulse this, it is now aligned with that axis. And I believe if we look at, this is, oh yes, so if we look at the item's parent, you'll see its z-axis pointing that direction, but this thing decided to align this direction. But it's aligning these nodes align with the global axes, not the local axes. If you wanted to align these with the local axes, that's where you'd use these. So, for example, say I want to set our cylinder's up axis, the green axis, and we want this to point in the same direction as this cylinder's, its local z-axis. So instead of using global z, which aligns it with that direction, we want it to face this way. Well, we can do that using the global direction to local node, and as well as the forward node. So since we don't have nodes to directly get a local direction in this case, whereas these are global, we don't have nodes that allow you to get local. You can construct a local direction by first getting the direction that you're interested in, which in this case is the forward, which is this z arrow. And we want to make that local. Now, since what the global direction, or what the global to local and local to global nodes take is a direction, they output a direction, but they also input a slot. And what this is this is the parent of the item you want to convert that space into. So in our case, we're just going to use the cylinder itself because this cylinder is parented to this one. And we'll see that this is some... Oh, actually, we want this to be here. So actually, in this case, since we're going from root, from global space to local space, we actually don't need to plug anything in here because this defaults to root. And now if I plug this in here, these arrows are up that we just set, and the forward of that slot now match. So regardless of how I orient this, I can pause this, change this, and it will align itself there, like so. There are more uses to global to local and local to global, but this is one of them. I'll go ahead and leave this there for now. We can continue. Now, I will note that with these two categories of nodes here, there are a couple at the bottom that I'll get to in a moment that are kind of a special case. But before we get to that, next we have our global and local component setters. Now, when I say component, I don't mean components like these components and inspectors. I mean the component parts of a transform, which is the position, rotation, and scale. And what these nodes do is, given a slot that you want to transform, you can set the position, the rotation, the scale, etc., either globally or locally. There's also convenient nodes here if you want to adjust the position and rotation, but not touch the scale. Now, for the bottom of these, there is a set TRS and set global transform matrix. what these do is, and you'll see these take a special type. These are a matrix, a float 4x4, is internally, the position, rotation, and scale is stored as a 4x4 matrix. And these nodes allow you to, given a matrix directly, you can set the transform, rotation, and scale of something all at once. I wouldn't use these unless you know what you're doing with these transform matrices, because they can get a little bit funny. I would more so recommend, if you're wanting to set all of these values all at once, use these, which is the set global transform and local transform nodes, which allow you to set position, rotation, and scale. Moving on, finally, in the last subcategory for transform nodes, we have the nodes that allow you to transform from one space to another, not just from global to local and local to global. Essentially what these do is, say I have two cool sets of cylinders, and I'm going to rotate them all funny and move this one over there and all that. What this essentially does is, let me get rid of our Logix here. Let's say I want this cylinder to be in the same relative position to this cylinder as this one is to this. So you can see they're kind of in completely different positions and rotations and all that stuff, and I want them to be lined up relative to these individual separate objects. Well, we can do that using the, let's say, transform point node. And we are transforming from our first cylinder's space to our second cylinder's space, because we're wanting to take a transform thing, a transform component from this space, this local space of the cylinder, to this one. And we are wanting ultimately to use the local position of our parented cylinder, like so. Now, if I set local position using our output here on this other cylinder, when I set this, boop, they share the same local position. So what I did here, it's actually a little bit unexpected, but this is a great thing to demonstrate as well, is these two objects are completely separate. I can move them around independently. But what I did is I said, okay, take this point, even though it's relative to this object, get me that point relative to my new object, and I want to put this cylinder there, regardless of where it is. So if I pulse it again, it goes here, even if it's a separate object. So you can essentially take a point and transform it from one slot to another. It's pretty cool. So say you have, like, for instance, two objects and you're wanting to keep something relative to another point for whatever reason, that's how you can do that. You can swap these around and mess with these. These are all in local transformations and stuff, but this works for global as well. Ooh. We have had a node grabbed. Oh well. So, this is the gist of transform. It's complicated and such, but generally it allows you to, given positions, rotations, and scales, it allows you to transform something from one space or parented object to another. Because at the end of the day, a slot is just a point that has a position, a rotation, and a scale. It can be moved in 3D space, and you can parent things to it, which have a local space relative to the thing that they're parented to. And these nodes allow you to go between local space, global space, between two different spaces, and etc. Aragubas in chat mentions quaternions. Yes. So rotations in this case is a component of transforms, and rotations are internally stored as quaternions. That's so we can avoid gimbal lock, which is a complicated thing to describe.
And can be a pain to fix.
Which is why we have quaternions.
Yes.
Next up, there is one small subfolder in the transform folder, which is bounds. And inside the bounds folder is just a few nodes. But these allow you to get a bounding box from something and get the information from said bounding box. So say I have the bounding box of these two cylinders. If you want to see it, you can select it with a gizmo, and the outlined area of the object is that bounding box, and these nodes allow, given in this case, the compute bounding box allows you to, given a slot and a coordinate space that you want to use with it, it will give you that bounding box. And then you can encapsulate a point inside the bounding box, transform the bounds from one space to another, like we did over here with points. And you also have a node which gives you information about the bounding box, like what is its minimum value, maximum value, where is its center, and how big is it? I've used this a lot for a tool that I have been working on, a kind of a personal project of mine, where I can kind of place objects on a grid and so on. And this, the bounding box is essential for that, because I need to know how to place something relative to another thing, relative to the bounds of it. Very nice.
I realized I used that before a long time ago. Using this box generator. It
a good example, because
places a whole bunch of boxes there, and then I calculate the outer box, and that's how this glass encapsulated box is generated.
I'm assuming, did you by any chance use the encapsulate bounds or encapsulate point nodes?
I think that predated that.
Ah, well, you'd have to do it manually. Oh boy. Well, there's nodes for this now.
Could probably open this up for when we go over examples.
Move our handy dandy cylinders over there. And there are nuances to the transform nodes, specifically global to local and local to global, how to transform between these spaces. It's a little bit complicated to discuss without doing lots of experiments. Like a lot of these nodes I kind of learned on my own. Like these, I didn't know for a while that these, the global axis setters set, well, global axes, regardless if it's parented to something or not. And I think that's good to know as well. These nodes are the trickiest to understand, but if you think of the parent of a slot as that thing's root, that thing's origin, then these tend to make a lot more sense, because everything, when you say local, everything is relative to that object's parent, which is what you would usually plug into the slot inputs for these nodes if you're converting to or from a certain object's transformation.
I unpacked it, so... This is what it's using.
Yeah, so given a... We do have a question from Caio Volpes. Are transforms synced with everyone, or can they be changed locally? So that is a more general question that I think has to do with drives. But if you aren't driving the position, rotation, or scale of something, then yes, they'll be synced for everybody. But the moment you drive these values, then no, they will not be synced for everyone. Unless, of course... Okay, I should mention that if you drive these, they have the potential to desync between users, because you could be controlling the values differently for each user, or you could just be driving it with a mathematical function, which is the same for each user. So in that case, it depends on what you're doing, but you can have these be different for each user if you want. But yeah. That's that. Back to this. The bounding box nodes here I just mentioned is what this code does is it generates all the objects, and then it will, given the slot that contains all of these objects, which has a bounding box naturally, it will compute that bounding box, and then Aegis uses the size and the center of that bounding box to set that glass cube dynamically. Regardless of what is inside of it, you can even put some other random object in there and it will use that to encapsulate the bounds around it and encase it in glass in this case. There's also there aren't many transform nodes in this specific set. Huh.
But yeah, this was like, I figured I'd bring this out because I just remembered it does use the bounding box as a input function. So
Nice. Volpe says, so for example, a darkening sphere that is set to a person locally instead of, say, making more per user, that's something that wouldn't be synced if driven? Yes. So if you were to drive the position, of something like that, then you could have one object that is locally taking the global position or whatever of each user's head. So you could have something like that per user, and everyone would see something like that around their own avatar, but there's only one object. It's all the same object, it's just being controlled differently for each user. So you could totally do that too. Now generally that applies to drives as a whole, is when you start driving something, you can do different things for different users. And yes, it is. Aragubus says that's good for optimization. Yes, it's one object versus n number of player objects in your world. I've used that for quite a few things myself. When you only really you want something to be the same for each user, but you don't want to have to duplicate the object for every user. It's a good way of doing that. But, Aegis, I think our next topic for transform is the transform nodes,
Components.
or not nodes, components, if you would like to start us off.
So, when you attach a component onto an object, there is a category also called transform. Now, a lot of them mainly revolve around the drivers, but there are quite a few others in subcategories here. And to kind of start off, mainly we'll cover the drivers and kind of go through what we can cover as we go. A lot of these are self-explanatory, but there's definitely plenty that we can cover, and a lot of them are used daily.
Oh, well, you
Nice.
accidentally just added a component. I swear you added a spinner, like, subconsciously.
The spinner subconsciously, okay, yeah, no. We already got spinners, they're just on there.
Fair enough.
Yeah. But yes, where was I? Yes, there is a lot of these are very much self-explanatory. Auto look at user, axis aligner, axis panner.
I will note
Rotation.
that there are, like the axis aligner there are a lot of aligners in here. We've got the axis aligner, circle aligner,
Where's grid?
object grid aligner. And what these do is, when you add an axis aligner, for example, it will align something to what it needs to. In this case, an axis, or you want to align something to a circle. You can do that. You want to make something in a grid. You can use the grid aligner, for example.
A good comparison would be Blender's array tool or modifier.
Yes, exactly. We have a question from Aragubus. Are there components like Logix nodes, but with a different interface? I think I understand what you mean by that, but essentially, components. There are some components. There are some components that behave like their Logix counterparts. However, there are a lot of things that you can really only do efficiently in Logix than you can in components. Now, there is some statements floating around that doing something via components is faster and more efficient than doing it with Logix, and I'm here to say that is not true. Use Logix, use components. They're designed to be used interdependently at the same time. They cover each other's weaknesses, and they are pretty much the same performance, so that's not something necessarily to work out. If it's easier to do in Logix, do it in Logix. If it's easier to do it in Components, do it in Components.
It's the same thing with the myth about slot count as well.
Mm-hmm. Archibald also says, oh, there's different ways of doing the same thing. Yes, just like any kind of programming language, which this is a node-based programming language, there's many different ways to achieve the same goal.
And with each Logix node, it actually is also made out of components like anything in the world.
It's all components.
So, always has been.
Always has been.
And I realized why I've been accidentally clicking it. I think my trigger's clicking it twice for some reason on occasion. So, yeah. And with these green ones right here, usually that means you have to type in something or it gives you a list. For example, Boolean value driver. Give it a sec to load. You have all these different types, or if you want to set a custom type, you can as well. Boolean value driver. For example, you can drive a value depending on a Boolean. So if I type in like an integer right here, Boolean value driver int, if it's on false, I set it one thing, and if it's on true, and changes it to something else, I can put in a data stream here.
Also, just to demonstrate real quickly how they're saying that there's multiple ways you can do something. Yes, this is a great example, actually, of how there is a component there's a component analog to Logix. In this case, the Boolean value driver is exactly the same as the conditional operator here, which is located under operators in Logix. So given a Boolean value, it chooses either the first or second outputs, which is the same thing here. Given a Boolean value, it outputs the first or second value. So there are perfect analogs between them, but there's also a lot of things that you can do in Logix that is a lot harder to do in Components, or just downright impossible. Use them both. Let's see. We also have a question from Caio Volpes. When dynamically aligning something to a circle, is it better to do the math in Logix, or is it better to do the circle aligner? It ultimately depends. If you're having a circle that moves around and does other things aside from just being a circle, you probably want to use Logix so that you can animate it or do whatever else you're wanting to do with it. However, if you're just lining things up in a circle and you have the hierarchy layout to allow you to do this as you want, use the circle aligner. It's a lot more efficient.
There are also parameters that you can play around with the circle aligner as well, like the arc, offset, radius, and even axes of it. So, yeah.
You can even add items manually, or you can check the auto add children box so that any slots you add underneath the one that has the circle aligner will automatically get aligned to the circle you've defined.
And this applies to all the aligners pretty much, but they would probably have different parameters. So a lot of them share similar parameters as well. Let's scale this up here. Now, some of the most notable ones. Copy global transform is something I've also played around with as well, where essentially you just give an object, kind of like how you did with that, where it just places the object locally on there. What it does, you set the slot, and you can choose if you want to drive the, let's just copy global transform. Now it's on this box right here. I can't grab it anymore as it's assigned to that. So right now what it's going to do, I'm going to take this slot here, place it under here, and it's copying its transform, even though that box is part of the root.
We can see it's being driven now, which means it's being controlled by something else. And even though this cylinder that it just attached the cube to is not even in the same space, it's essentially using the global transform Logix node, like we described earlier, saying, hey, using these values, assign these values to my cube, and it will follow it regardless of where it is, what it's attached to, and etc.
There's a couple other similar ones too that have been useful. Another notable one is auto. Oh, there we go. Another notable one is position at user as well. There it is. So what that does, basically does the same thing, but rather an object, a certain user, or even a local user. For example, people have done that specifically for like heads-up displays or skybox elements that you don't want a parallax effect with. For example, dome of stars in the sky that when you move around, it won't have that parallax effect. You feel
Moving
like
with
it's
you.
way far away. Although the effect could be broken if you scale yourself large enough, unless if you count for that.
We have a question from Kai Lopez. What's the point of float n drivers, which is things like the float 2 driver, float 3 driver, and float 4 driver?
Okay, well then let's bring in that one. I don't quite remember what these are doing
So
for.
what the float 2, 3, and 4 driver components allow you to do is, given a set of float ones, just a number, you can supply that into the X, Y, Z, or W components, depending on how large of a float 2, 3, or 4 you're combining, and you can essentially combine these 4 numbers into one, which is exactly the same as the pack operators in the operators
Same time.
in the operators folder as the Logix nodes. That is essentially the float 2, 3, and 4 drivers is the same as the pack XY, XYZ, and XYZW nodes.
So it'll be like 2. Okay, yeah, you got
Three.
it. Look at as well is also a useful one too. It basically changes the direction of an object to look solely at another object or user. The only difference between look at user and auto look at user, the auto look at user basically looks at the nearest user that is near it, and it has like a bit of a smoothing to it as well too.
Whereas look at user, Seeker says, that was a pack XYZ quick draw you both did. Yes.
Yes.
I think it would have been a tie.
Yeah, I couldn't believe that, actually. I was just sat there looking at the cameras, and I noticed they literally both pulled that component out at exactly the same time, and I was like, wow.
Synchronicity.
We're not being driven, we're in sync.
These two are quite useful as well.
Do you know that's kind of relevant to the whole transform thing being in sync, hey?
Yes. Mirror transform.
The mirror transform and multi-bool condition driver. This is pretty much self-explanatory. You basically have an object. Actually, just to kind of, without applying to all these different objects, to kind of go over what it does, you get the mirror source, which is like a point in the middle of the mirror. Actually, I do have a example for this somewhere. Messed around with it years ago. It was actually to make like a mirror brush. Once I find it real quick. There it is. Wow, didn't take that long. Okay. So, let me open this up and find the mirror component.
We do have a question from Aragobas, but I will get to that after you demonstrate this.
Unless if I did this via Logix and mirror transform. There we go. So the mirror plane is the quad. So I'm literally using the quad as the object as well too. And that's what's moving that other brush over there. And the mirror source is, assuming it was this one, right? Yep. This is the one that I am taking the reference for.
So you're
And of
ultimately
course-
defining a plane, and you're saying, okay, the mirror sources take this position and mirror it across that plane.
Mm-hmm. And the Logix is so that I can...
Oh no,
I see.
it broke.
It was supposed to be able to, like, mirror it, but you can see it move around the tip of the brush. I think it's because it's not clicking in properly. Well,
Oh well. Well,
something I can
back
work
to the
on down the
question
line.
from Aragubas. What are these panner components?
Panner components. Ooh,
Panners.
I have used a lot of those.
Let's see. So, panners, which you can find under transform drivers. Scroll down a little bit. We have panner 1D all the way up to panner 4D. And what these do is these, like the name suggests, allows you to pan things, like this waterfall. For example, this is using a panner 2D, and it's saying, hey, take this texture, take the y coordinate of the texture, I believe, and just continually increment that number forever. And we can see here that that's exactly what it's doing, is the x value is always 0, but the y values are continually going up at a certain rate. And if we look down at the panner 2D, we can see that, oh hey, our speed is 0.15, so every second it will continually increment the y by 0.15, and we have a repeat set to 1, so once it reaches the value of 1, it'll go back to 0, and continue. And one thing I want to show is that if we take so say you have let's say a color that you want to linearly move between, one way you can do that is we can create another nice node underneath transform, which is the value gradient driver. And let's do type color. What this does is you can have a bunch of points. Let's just say 0 and 1. Let's pick, I don't know, red and blue, just to demonstrate. And I'll add an output here so that we can see what we're doing. Color. We'll put our target here. And what this does is, based on a amount between these points, it will linearly interpolate, as you can see.
On the waterfall.
It will linearly interpolate between our colors here. Now, of course, we can have absolutely more than 2 colors, and you can see, regardless of these orders, it will interpolate linearly between those colors. Why do I bring this up? Is, say you want to automate this. We can have a panner 1D here, and we can drive our products. Set a speed of 0.1, and we can see it's moving along now at a speed of 0.1 per second. It has a repeat of 1, so once it reaches the end, once it reaches 1, it goes back to the beginning. But let's say we want this to kind of go back and forth between these values. That's what ping pong is for. So if I enable ping pong, it will reach 1 and go back to 0. Let's speed this up a little bit. Goes back.
I also did it with the Panner 2D, if you notice.
Oh yeah, the Panner 2D now ping pongs as well, so it goes up and down, back and forth. That's what ping pong does.
Mm-hmm.
And this is great if you want to continually move between a set of values, or in this case, a set of colors. You can do that with panners set to ping pong. Hmm. Very nice.
Yep. And value gradient
Go ahead and set
drivers
these.
are incredibly useful.
Oh
Making quick
yeah.
animations or like changing dynamic objects.
Yes, indeed. On the topic of these, say you want to just swap between one value and another, that's where you can use your Boolean value driver or Boolean reference drivers. If I set this to color, we can see you can just pick between two colors. Let's say we want to go between pure red and pure green. And we have a color here that we're manipulating. Then, based on the state of the value, we can go between red or green. But another handy component for underneath the transform category that does have a perfect analog in Logix as well is the transform driver's smooth value, which is equivalent to the smooth lerp under the math category in Logix. This, just like the smooth lerp, allows you to interpolate values over time. Not necessarily linearly, but it allows you to do it over time. So for example, I want to smooth this color value. Let's take our Boolean value, put it here, and now we're taking the output of the smooth value and plugging it in here. Now when I change the state, it smoothly transitions between our two values. And if I decrease the speed, then it happens more slowly. Now this is a smooth transformation, so if you were to look at the values of the color gradient driver, it would linearly interpolate like this from one value to another, whereas the smooth one will kind of look something like this, so that as it starts off, it starts slow and then speeds up and then slows down once you get near your end point. It is a form of interpolation, but it's not linear. And that's how you can do that with smooth value. We have a question. I heard the camera was weird, so here's your two curves. Linear versus what the smooth value and smooth lerp components do innately. So it's not linear. See, we do have a question from Aragubas. Is it a quadratic curve? Maybe? I'm not entirely sure. It's kind of a time-dependent curve because if this function, if the smoothing function had infinite precision, then it would never actually reach the target value because it just says, okay, here, interpolate halfway more, and keep going halfway, and it gets very close. Eventually, of course, due to precision, you do reach your end value. But that is the kind of curve that it is. Going back to the transforms folder, though.
There's one I also highlighted too, right underneath the mirror transform.
The multiple condition driver. This is equivalent to the Logix nodes and, or, and not. So this is logical combinatorics between various Boolean values. So say you want something to be true only when two other things are also true. You can do that either with an and in Logix, or you can do it with a multi-bool condition driver with both of your values here and the mode set to all, which means the output will only be true when all values are true. You also have any, which is when any of the values are true, then the output is true. That's equivalent to an or. And you have none. So when all of the values are false, which is equivalent to a not and or a NAND, which we do have a NAND as well. NAND. Yeah, that's more accurate. So we have all, any, none. And of course, each of these values also has an invert tag. So you can say, okay, I want when all of these values are true, except this one. That would be essentially equivalent to saying all these values except that one. So this has another direct analog. Ooh, thanks for the 25 bits, VRM. We also have another question from Aragubas. I'm also apologies if I'm ever mispronouncing that name. I have a question. When moving something with transforms over time, do I have to multiply with delta so that the movement is not dependent on the frame rates? So there is a delta node which gets the change in something between frames, but if you want that value to be frame independent, you want to multiply by delta time. So let's say, for example, let's get the global transformation of something, and we want to get the change in it using delta, and we want this change value to be frame independent. You would then multiply it by delta time, and this would be your frame independent change value. There, we also have a division by delta time if you find the need to do that too. And these nodes work with float 1, 2, 3, 4, all of them. You can tell because I can just take this float 3, plug it in here to the DT, and it automatically converts to the right type. So another thing to note is how you can tell, specifically with the values that have more than one component, like float 2, float 3, and etc. You can tell on the wire that they have more than one component because they have these lines. This is a float 3 because it has 1, 2, 3 lines. If I were to get a float 2, which has 2 components, then its wires have 2. And the only reason float 1s in this case have no lines like that is because it's just a single value. You can have up to we have bool 4, we have float 4, I believe we have an int 4. There's a lot of data types that support up to 4 components you can see here. And yes, this is mildly interesting, but you can have a float, or you can have a bool 4, which has 4 Boolean values instead of a float 4, which has 4 float values. And yes.
This is incredibly useful for calculating projectile trajectory or even vehicles as well too. I've seen it used heavily for that.
Anything that anything that's changing over time that you want to be essentially synced between all users, regardless of their frame rate, you want to make sure you include delta time, be it multiplying or dividing by it, to ensure that everything is based off of your so it's independent of your frame rate. Kyle says, I hope that is using BitLogix. Yes. These are just 1 bit. 1 bits. Let's see. Since we only have a few minutes, let's see what other very nice nodes, or not nodes, components are in the transform, which there are a lot. And a lot of them, I definitely recommend experimenting and playing with these because it took me quite a while to learn what all of these do myself, but they're really nice once you get to know them. A very nice thing that transforms things, at least in rotation, that is like the definition of what Aegis does is the spinner. Before we get onto a spinner, though, we do have another question from Aragabrus. What does the ray driver do? Well, let's get to that after the spinner. Let's just say demonstrate speed of 55. What are we spinning?
I think it was this box.
It's a cylinder. Oh, okay. I don't think it likes all these components what would be added to it. But essentially what the spinner does is it lets you spin something on an axis. I'm sure you can demonstrate that while I look at the ray driver.
Right here.
Boxy,
okay, we can wobble this
wobblers.
too.
Yes,
I got
we
it.
can totally wobble it.
Yes. So there's 2 things you can wobble per se, but this is the spinner component, so I can change the speed of it. So if I wanted to slow this down, I can do so. I can also put in a negative value and reverse its direction. You can also change the axis of where it's spinning to. And of course, the offset is
Oh, my inspector.
also self-explanatory as well too. And if we're going to go over the wobbler, the transform drivers wobbler 3D in this case, by default, it actually connects to the scale. But first off, I want to turn that off and actually, what is this position here? I'm just going to make a parent object to kind of zero that out. And I'm going to drag the position into the wobbler here. And by default, well, it just has a base value that I have to just turn off here. So the magnitude, alright, actually, let's make a move up and down. So let's change the magnitude, which is how much it moves. Oh, man, it's lagging there for a second. There we go, magnitude of 10. We can change the base value, but I'll leave it at 0. Let's change the speed to 1. And, yeah. That's definitely how a ceiling fan works. So let's change the magnitude to 1 for now. There we go. We have a reciprocating ceiling fan. And let's duplicate the wobbler again. And this time, we're going to plug it into the scale. And let's set the base value to 1. Set the magnitude to 1 of all of them. And add the speed of, say, 5 on all of these. And it wobbles its scale. That looks very dangerous to be around. Now, if I recall, when you drive a magnitude of a wobbler, it dynamically changes how intense the wobbling is as well, too. So I've seen people do that with, like, talking avatars where the head would, like, wobble in a cartoonish way when they speak. So we'll just leave that there. You can cover the rest.
Mm-hmm.
Now, I believe you're working on the ray.
Yes.
driver?
So the ray driver is actually one of the 2 components in the transform folder that deals with raycasts and raycasters. However, the ray driver is actually not a component I've had to use very much because it's a little bit interesting. There is actually a component that uses the ray driver. And there's a component that uses another component, and it's the laser component. So if you were to add the laser component to something, then it makes a laser, and it also creates onto it a bunch of different things, like a segment mesh, which is the mesh here, which you can use for your laser, and it also includes a ray driver. So what this does is, given a distance and 2 points, it will, I believe, essentially raycast from 1 point and in the direction that you want, and it will set the second point to the thing that it hits. For instance, we have here our first point here on the ray driver. Here, point A, is the start of the beam. And point B, we're saying, okay, we want to set the other end of this segment mesh to wherever the raycast hits from the ray driver. In this case, we have point B. And you can give it an origin and a direction.
We have a question.
That's how the ray driver works.
Oh. If you're talking about okay, I see. So if you're talking about, for example, wagging tail, you would need a different component. So you know what? I'll just do it on myself. Just get a portal as well too, so I can actually see my own tail. And tail base, and then we go there. So right now, I'm gonna add a parent bone here. Reset its rotation and position. Should be back to normal. Okay. I will make another parent here too. So there's another component as well that deals with specifically rotation, because that's quaternions compared to flow 3. So we go under driver, we go all the way down. It may not do the exact same kind of movement that you probably want, but it's called a wiggler. So in this case, let's look at, we got here, I'm going to do it on the y-axis, so that'll twist it that way. So magnitude would be, let's just do 5 degrees on the y, and a speed of 3. And then let's do a magnitude of 10 instead. There we go.
You can see the gizmo, as you can see with the gizmo there, it's randomly on that y-axis, moving back and forth at a speed of 3. At a speed of, oh, no, it's even a lot more. So you can see it's random, essentially random motion based on a seed that you can provide on the wiggler, which allows you to have something randomly move like that.
Mm-hmm.
Let's see. We do have another question from Aragubas. Does it tell you what object that the ray hits? In this case, no. It just gives you the point. If instead you want to do a ray cast and you want to know what you're hitting, we actually have a Logix node for that, which is under physics, and there is both raycast 1 and raycaster, which allow you to get the hit collider of either one raycast or a continuous raycast, and just demonstrated that he's shooting these nodes with a weapon we created in a previous stream, and it gets the object that it hits and parents a temporary decal to it, I believe.
And uses the transform nodes to set its rotation and position. Because it places a little decal when it hits something.
Mm-hmm. So if you want to know the thing that you're hitting, use these nodes.
Mm-hmm.
And I just noticed that it is about time. Test time.
Wow.
Ah.
As well as the car also uses a lot of nodes in regards of delta time, transform, and even raycast as well, though we've probably already shown the logics of that plenty of times before.
Mm-hmm.
And to also let Emerald Sundix know, this vehicle version is the one that Stantif made, which is the vehicle standard system, not the original Atom.
Okay, so Aragabus did ask about the voice modes in Neos. As I say, we do have the mute, whisper, normal, shout, and broadcast. Shout enhances your voice slightly, so people can hear you a bit further away, and broadcast means you're in someone's head. That's the easiest way of putting it.
Heard from everywhere.
Everywhere.
Another thing to note is whisper. Given a bubble essentially that forms around you, it reduces the sound of all audio except for people's voices who are within the bubble. Like Aegis could have been talking right there.
I'm gonna continue talking.
Or the ring.
Yes.
Nobody will still be able to hear you, Aegis, because of the camera.
Yes.
He actually has... He doesn't know where the camera is, that's the problem. So he's now out there trying to find the camera.
Yeah.
You cannot be heard.
Do not broadcast in public unless you want people to hate you. Yeah, that's right. Broadcast
Or
is
if you're
very...
making an announcement.
Yeah, if you're making an announcement, that's when you use broadcast. Okay.
Hence the name broadcast.
So as I say, we've got to the end of the workshop now. Massive thank you to Ivy and Aegis. We're not going to be doing workshop after today for a bit now. We're going to be taking a hiatus from doing the workshop. So that could be a month or more. We don't know yet. We're practically running out of projects and basic ideas to cover. We don't want to go into advanced things yet. So we are going to be going on an indefinite break with workshop. And, you know, it's really sad to say that much, but I do hope to try and sort something else out for Wednesdays where, you know, we might do something, we might not. You know, we could do build battles.
Ooh, that'd be fun.
Have you and Aegis have a build battle?
Oh, no. Things we'd make.
We'll
Question
still...
is what?
We might still do little meetups on Wednesdays at the usual times that we do workshop, maybe, yes. Just for people to come and still help out. We might still do a workshop, but it won't be a broadcast thing, is what we're saying. So, you know, yeah, we've already gone through community ideas, Caillou, and some of the stuff is not feasible on stream, unfortunately, as much as I'd like to cover that kind of stuff. It's just not feasible in the hour block that we allocate ourselves to have that done. But as I say, you know, there's a lot going on, and especially, you know, New Year and all that lot.
Mm-hmm.
No, we don't do mod showcases, unfortunately, because that's not something we cover, because that's not a officially supported feature.
Yep.
Okay, and I will quickly take this question. I have another question. Why does every time someone spawns a camera, even when I'm not looking at it, my FPS drops? Because you're still rendering that camera preview, regardless of if you're looking at it or not.
Yep.
Because
if you don't want to lose performance, clean up your cameras, clean up your mirrors when you're not using them.
Yeah, it doesn't matter if you're looking this way, because you know if the way my if viewpoints worked based on me looking that way, you wouldn't see any of this rendering behind me.
Yep.
Unfortunately, because of the inherent way that VR works, you can't occlude stuff behind you because the system can't keep up with you. If you spin around too quick, you might end up with nothing rendering in front of you because the system doesn't realise. Yeah, even on desktop, yeah, it's still the same stuff. Unfortunately.
Mm-hmm. We have a quick question from FoxyBoxy. Why, when you put in a rotation, if you put 90 or negative 90 on X, it sets Y and Z to 180? Because quaternions, the X, Y, and Z representation there is an Euler representation, and that has gimbal lock, whereas the actual quaternion under the hood does not. And because of going from something that doesn't have gimbal lock to something that does, you ultimately get interesting different rotational values like that. Oilers.
So yeah, I'm going to say, as I say, a massive thank you, as I say, to RUV and Aegis for helping me out with this. and I hope you guys join our stream on Friday. I don't know what we're doing on Friday yet. Although I might be able to ask someone. Hey, Nexlin, are you around?
Yeah, I'm around.
Come on over.
Hello.
So, what's the plan for Friday?
Plan for Friday is going to be Christmas theme stream, so we're gonna do everything Christmassy, probably about like little virtual gifts and presents that I'll be making new this year, and then we'll just be handing out gifts to random people that come inside of the stream area. And we're gonna be holding off for doing a showcase until for next month, since we only have just around like 2 or 3 worlds to actually showcase. So we'll save that for next month, and then hopefully I'll show off those worlds as well, but you know, we'll have for next month and additional for everything that.
No, not VR giveaway. It'll be like Neos giveaways, like storage, merch.
Mm.
But it's more than likely to be storage.
Yeah.
But, and yeah, to answer your I like how Cinder's like,
I wasn't actually meaning that rate. I was meaning like, you know, cute like little virtual gifts, like then they would open up in like little presents. But we can absolutely give away storage, you guys, because seems like you're now inclined for that now. So okay,
we can do a little
giveaway.
Yeah, we usually do that at Christmas. We do a little Pictionary thing to give away a bit. So yeah, we might be giving away.
Yeah, we'll do some Pictionary, guys. Absolutely, we'll do Pictionary for you.
Yeah, to answer your question, every so often Nex is hiding in the workshop. He hides in the basement.
Yes, they got me tied up down there.
Yeah.
Basement dragon.
But yeah.
Yeah.
Oh, that's awesome. That's really cool.
Ooh, translation.
Ah! I was
job.
doing a Welsh translation, but I kind of lost track.
Ah.
But yeah, we are going to get shifting now. The workshop is going to be open for about, I'd say about half an hour now, given we've gone 20 minutes over. So we're going to be open for half an hour. So please feel free to search in the active sessions, look for the workshop, and you can come join us. Come chat to us, ask us for help and all that good stuff. So, as I say,
Come say hi.
we won't be returning. I was going to say we'll be returning, but we won't be returning soon. Sadly. So we are...
At least on stream.
At least on stream. So we are going to head off now, and once again, thanks all for being here. You are all absolutely awesome. I love you guys. Goodbye.
Yay. Bye, everyone.